All right, in our last video, we learned how to add integers together, and we noticed that when we add numbers that have the same sign, we're combining their values. So a positive plus a positive will give you more positives, and a negative plus a negative will give you more negatives. And when you're adding numbers that have different signs, there's a canceling effect that goes on. And if there's more positives, your answer ends up positive, and if there's more negatives, your answer ends up negative. But what happens when you subtract integers, okay? If you're taking away negatives, or if you're taking positives away from negatives, and so on and so forth. What we're going to do is we're going to use what we know about addition to help us figure out a rule or a pattern for subtraction, and that's called inductive reasoning. We're going to reach a conclusion based on a pattern of examples. So in this left column, I just have some examples of addition problems. So we've got a pattern here where I'm adding a different number to 8 every time, and we're just going to see what happens. And then on the right hand column, I have some subtraction problems. We're going to try to make a connection here between addition and subtraction. So we're going to run through these problems here and see what we notice, or if we notice anything at all. So 8 plus negative 3, well, we learned in the last video that if we add numbers with different signs, they kind of cancel each other out. So 3 positives are going to get canceled out here, so that's going to leave me 5. 8 plus negative 3 is 5. 8 plus negative 2 is going to be 6. 8 plus negative 1 is 7. 8 plus 0 is 8. 8 plus 1 is 9, 8 plus 2 is 10, and 8 plus 3 is 11. So we notice that the sums keep getting larger here by 1 every time we increase what we're adding to 8. Well, that makes sense. Well, let's look at the right-hand column here and do these subtraction problems and see what we can notice about subtraction. Well, 8 minus 3, we're subtracting 2 positives. We already know how to subtract positive numbers. We've been doing that for a long time. 8 minus 3 is 5. 8 minus 2 is 6. 8 minus 1 is 7. 8 minus 0 is 8. Now, let's extend this pattern. What should 8 minus negative 1 be? So what we're doing here is we're decreasing what we're taking away. So we're taking less and less away from 8 every time, and our difference gets larger and larger because we're taking less away from it until we ultimately take 0 or nothing away from 8, and we're left with 8. Well, what happens when you take a negative away? If you take a negative away, that's actually going to increase the value. Taking negatives away actually increases the value of something. This next number, or this next difference, has to be 9 if this pattern holds true. And 8 minus negative 2 then would have to be 10. Taking negatives away increases value. And then 8 minus negative 3 is 11. Well, that might seem a little bit strange, but let's try to make a connection here between these two columns. What do you notice? Well, hopefully you notice that we've got the same answers in each column, so these two expressions are actually equivalent. These two expressions here are equivalent. These are equivalent. These are equivalent. These are equivalent, and so on. So it's almost like for every addition problem, we can write an equivalent subtraction problem, and vice versa. For every subtraction problem, we can write an equivalent addition problem. Well, what do they have in common and what's different? Well, the first number is the same in every problem. There's 8 every time, and we're obviously adding in the left column, subtracting in the right column. But what is the difference here? Here I'm adding a negative 3, and here I'm subtracting a positive 3. Here I'm adding a negative 2. Here I'm subtracting a positive 2. Here I'm adding a negative 1. Here I'm subtracting a positive 1. Here I'm adding 0. Here I'm subtracting 0. Here I'm adding a positive 1. Here I'm subtracting a negative 1. Adding a positive 2. Subtracting a negative 2. Adding a positive 3. Subtracting a negative 3. Well, what do these pairs of numbers have in common? Negative 3, 3, negative 2, 2, negative 1, 1, 0, 0, 1, negative 1, 2, negative 2, 3, negative 3. Well, these are opposites. They're the additive inverses. So what we should notice, or what we can notice, is this simple fact that subtracting an integer is the same as adding its opposite, or its additive inverse. Okay, so if we can turn a subtraction problem into its equivalent addition problem, then we only need to remember how to add numbers together to do subtraction. It's kind of cool. So here is the conclusion. Subtraction is the same as adding the additive inverse, or adding the opposite. So instead of subtracting a number, we can actually add its opposite and get the same result. So we don't always have to do that, but it's nice to know that we can do that to help us with some more difficult problems, because when negatives are involved, things can get kind of confusing and difficult. So it's nice to know that we can do this. So we're going to find each difference of these numbers. We're going to subtract these integers, but what I want to do is write an addition problem that would be equivalent to it, and then we're going to just pick which one we think would be easier to do, and then we should get the same result. So 6 minus 15 would be the same as 6 plus the opposite of 15, which is negative 15. So these two expressions are equivalent. We're going to get the same result. So depending on which one you like to do better, this is going to end up negative. Since we knew how to add these, there's going to be canceling going on here. This is going to be negative 9. So I know 6 minus 15 has got to be negative 9 as well. So again, you can kind of start to see we can use addition to help us with some subtraction problems if we're not quite sure what the difference is going to be. Next one, negative 7 minus 8 is going to be the same as negative 7 plus the opposite of 8, which is negative 8. So negative 7 plus negative 8. These are the same sign. These are going to combine their values together. So two negatives is going to make more negative when we're adding. So negative 7 plus negative 8 is negative 15. That means negative 7 minus 8 is also negative 15 as well. And then the last one, negative 3 minus 12, it would be the same as negative 3 plus the opposite of 12, which is negative 12. And again, we've got the same sign, so we're combining these values together. That's going to give me negative 15. So negative 3 minus 12 is also negative 15. Let's take a look at a few more here to see if we can get the hang of this. 3 minus 5. Well, this one, I can kind of do this without changing it, but I'm just going to do it for fun. This would be the same as 3 plus negative 5, and 3 plus negative 5 is negative 2, and that kind of confirms that 3 minus 5 is also negative 2. Negative 10 minus 14 is going to be the same as negative 10 plus a negative 14, and again, these are the same signs, so they combine. That's negative 24, so this is also negative 24. Here, 17 minus negative 14. This is where changing to addition is really going to pay off when we're subtracting a negative number, because subtracting a negative often confuses middle schoolers. This is the same as 17 plus the opposite of negative 14, which is 14. 17 plus 14 is a much easier problem to do than 17 minus a negative 14. So we can do that quite easily. That's 31. So I know that 17 minus negative 14 has to be 31 as well. And then again, I'm subtracting a negative number. Negative 7 minus negative 11. This is going to be the same as negative 7 plus the opposite of negative 11, which is positive 11. Here, there's a canceling going on. There's more positives than negatives. That's going to be 4. So this difference has to be 4 as well. So these bottom two problems really exemplify when this strategy is going to really pay off. Okay, I'm not saying you have to change every subtraction problem to an addition problem. I mean, if you're given 14 minus 3, I'm not going to have you change that to addition. That would be kind of ridiculous to do that. Okay, we know that that's going to be 11. But if you wanted to, you could see that that's the same as 14 plus negative 3, which is 11. So it works out either way, but sometimes the addition version of the problem is easier. Sometimes the subtraction problem or version of the problem is easier. So I'll let you choose which version you like best, but you have to know how to write equivalent addition and subtraction problems. Also, we use subtraction to find distance on a number line. The distance between 2 points on a number line is the absolute value of their difference. If you remember, absolute value is distance. So if we find the absolute value of something, we're going to find its distance. So if we want to find the distance not from 0, but the distance between 2 points on a number line, we just find their difference and find the absolute value of that as well. So in this yellow box, I have the distance between A and B on the number line is the absolute value of A minus B. So you just subtract the two values and find its absolute value, and that will tell you how far apart those numbers are on the number line. So let's take a look at a couple examples here. We're going to find the distance between each pair of integers on the number line. How far apart are negative 30 and negative 22? Well, that's going to be the absolute value of negative 30 minus negative 22, which is the same as the absolute value of negative 30 plus 22, which is the absolute value of negative 8, which is 8. So these 2 points are 8 units apart. And then likewise, the distance between negative 6 and 5 on the number line is the absolute value of negative 6 minus 5. And negative 6 minus 5 is the same as negative 6 plus negative 5, which is the absolute value of negative 11. Whoops. So that's 11 units. So those 2 points are 11 units apart on the number line. Okay, so subtracting integers, change it to addition when it's necessary, leave it as subtraction when it's not, and you'll be just fine.